Hello everybody, getting ready to do lesson 11.8 of Geometry 1 Math Part 1. Part 1, 11.8 is rotations, and we have a class worksheet here of 32 points for you. And then we got 20 points worth of notes. Teachers, today's bell work is this. Whether it's dilation or a reduction or an enlargement, then find its scale factor here. So we started here with this, and then you figured it out. And then over here, find the coordinates of P prime, Q prime, R prime, and S prime here. And this is you figured it out. Okay, give your students 6-7 minutes for this. Okay, welcome back. Number 2, here's P to P prime. So this is P here. Now P prime would be Q to Q prime. And then, so 1, 3. This would be our 1, 3 here, and that would become -3 and 4. With this adjustment here, it would be -3, 4. And then Q to Q prime here would be 2, +2. And then for R to R prime, it would be, wait a minute here, 0, -1 for R to R prime. So the thing looks like it moves this way. And then for -1, 0 for S prime would be -5, and then 1 will be the adjustment here for our prime. Find the coordinates here using the given translation. So these would be your translations here. It would be right here. -3, 4, 2, 2. 0, -1, and then -5 and 1. Students, if you don't have that, write these solutions down. You'll get partial credit for it, at least in my classroom. And then for number 1, any enlargement here is 2.2. Here's your scale factor here. So this P prime object here, this quadrilateral, would be an enlargement of 2.2 times the original here. Okay, into our lesson. A rotation is a transformation in which a figure is turned about a fixed point. The fixed point is the center of rotation. The center of a rotation to a point is image form an angle called the angle of rotation. Rotations can be clockwise, counterclockwise. So we have a situation here. Clockwise would be something where the angle of rotation here would be something that you go in a clockwise fashion, as you can imagine. And then counterclockwise would be going in the opposite direction of how a clock goes. Rotation is a transformation in which a figure is turned about a fixed point. The fixed point is the center of rotation. This would be the center of rotation is here. The fixed point is the center of rotation. This is your center of rotation. The center of rotation to a point in its image form an angle called the angle of rotation. This would be the angle of rotation here, angle of rotation. The rotations can be clockwise or counterclockwise. Okay, called angle. Got that. A rotational symmetry. A figure in a plane has rotational symmetry. If the figure can be mapped onto itself by a rotation of 180 degrees or less. For instance, the figure below has a rotational symmetry because it maps onto itself by a rotation of 90 degrees. So we go 30, we go 60, then we go 90. So this would be a rotational symmetry because it maps onto itself by a rotation of 90 degrees. So it has rotational symmetry here. That's basically because it's a circle. Okay, students, in your own words, define rotation, then define center of rotation in your own words. I checked these on Friday in my classroom, teachers, so maybe you could do something like that. And then angle of rotation as well. And then rotational symmetry be in students in your own words. This will be included in your notebook guide. If you got those through the email, I can provide those for teachers, students, for home students. Example 1, identify rotational symmetry. So does the figure have rotational symmetry? If so, describe rotations that map the figure onto itself. So we got a rectangle. Yes, rectangle can be mapped onto itself by clockwise or counterclockwise rotation, 180 degrees about its center. So this would be where you could start here and then you could turn it 180. So this corner would end up over here. That'd be 180. Identify rotational symmetry again, part 1, this would be B. Does the figure have rotational symmetry? If so, describe rotations that map the figure onto itself. We have a regular hexagon here. How could you rotate that thing? It can be rotated 60, 120, or 180 about its centered here. So you can go 60, 120, and then 180. This will be a 180 for this corner here. And then, oh, that would be more. Go back and look at the video again, or get the PowerPoint. Those are also available too. Okay, so for another example here, identify rotational symmetry. You have a trapezoid. Does the figure have rotational symmetry? If so, describe rotations that map onto itself. We have a trapezoid here. Here are the bases. These are the legs of this trapezoid here. No, trapezoid does not have rotational symmetry. So let's go into our first guided practice here. Teachers, give your students 5 minutes. Does a figure have rotational symmetry? Same thing down here, a parallelogram and an isosceles trapezoid. Give your students 5 minutes. Okay, welcome back. No, trapezoids don't. And then yes, it can be mapped onto itself by clockwise or counterclockwise rotation of 180 about its center. So a 180 would just stick this corner over here. Everything would flip by 180 degrees. Here, if you flipped it around, it would be here. It wouldn't be in this position here. So that's why a trapezoid won't work for symmetry, rotational symmetry. And that was 11.8 part 1, part 2, part 3 available here, as well as worksheets, tasks, quizzes, tutoring, everything for homeschoolers, for classroom teachers. Email me. Thank you.